This is Turt, my three-wheeled omnidirectional robot. Stick around and I'll show you the design and build process, as well as how it works. The physical design for this project is pretty simple. The body again is a box with a lid and some features for mounting the control board and motors. The most unique aspect of this design is the Omni wheels themselves. I kept the individual rollers pretty short to minimize the gap in between them, and I also decided to use a piece of 3D printer filament as the axle since it was readily available and it can curve around the circumference of the wheel, so I don't have to deal with dozens of smaller individual axles. The filament is fed around grooves on the outside of the wheel, and it can be fixed at both of its ends. The rollers themselves are printed as two parts. The PLA core provides a rigid, low-friction surface to ride on the axle, and the TPU tire provides better grip on the ground. The code for this project utilizes the Excel stepper library for motor control and the RF24 library for radio communication. In the loop of the program, I take the commanded X and Y translational motions and the Z rotation, and I use it to calculate the speed and direction of rotation of each motor to get the desired motion. For this project, I'm using stepper motors because I want to precisely control the rotation of the Omni wheels. These came with these handy motor driver boards, but since I want to fit 3 of these inside the body of the robot, I'm instead going to create my own Arduino shield. With this, I'll be able to mount the integrated circuits for driving the motors directly to the board, as well as the connections between those and the Arduino. This way, I only have to worry about plugging in the motors, and I can clean up the wiring considerably. Here I have the finished version of TURT so you can see the advantages of an omnidirectional drive system. As you can see, it can drive both in the X and Y directions, as well as being able to rotate. By combining these commands together, it can also drive diagonally and rotate while translating. While the stepper motors are useful for this application because of their precise position and speed control, they also come with some downsides. Compared to brush motors, they're pretty limited in terms of speed and torque, and they also consume power even when they aren't moving.